Hi everyone. Today in class we were talking about observations, questions, and hypotheses again. So this is the last lesson that we'll have on this topic, and then next week we're moving on to discussing experiments. So we're going to move from talking about the hypotheses to designing experiments to test them. All right, so for today, we're actually going to take a look at a warm-up similar to what we did last week, and then we're going to take a look at an actual demonstration of a science experiment, because scientists answer questions using the observational skills, the question-making skills, and hypotheses. So when you get to see something new, you're going to ask questions about it, you're going to create a question about it, and a possible explanation by writing a hypothesis. Okay, so we're going to be doing one more day of practice. So on page 5 of your interactive notebook, and if you are in periods 1 and 3, this will be a little bit different from what you saw, but we saw in those class periods that the slides didn't work very well, so we're switching over to the notebook. All right. So you can open your interactive notebook to page 5, and you're going to title that page Assignment 2, Observations, Hypotheses, and Evidence. Okay, so here's how that's going to look. We have page 5, and this is set up very similarly to what we did on page 3. Okay, so on page 5, we have the date, Assignment 2, Observations, Scientific Questions, and Hypotheses. All right, and we have a column for observations, a column for question, a column for hypothesis. This is going to be our warm-up. We're going to be looking at a paintbrush picture, so we can label this warm-up. And this is similar to what you'll see on the quiz for this week, is you'll be looking at a picture and having to think about questions and hypotheses. And then down here is the demonstration I'm going to do for you with some copper and aluminum. All right. In both cases, after we make our observations, we'll choose one to help us create a question, and then the hypothesis should follow an if, then, because pattern. So we're just going to put that in here to remind us that we need all of those parts. All right, you can pause this video and finish filling in your notebook if you need to. All right, so here's our first scenario. We have a picture of some paintbrushes, and there looks like there's some sitting in a sink, and one is being held, and the faucet is on, so it looks like that's water being used on the brush. All right, so we can come up with all sorts of observations that are factual about this situation. So what I would like you to do is to pause the video and come up with some observations, at least 3 observations, and then I'll give you some examples. So pause now. Okay, so hopefully you came up with some examples. Here are some that we came up with in class together today. The first one is the observation that we have a person washing the brushes. Okay, and I guess that doesn't show up. All right, so there we go, a person washing the brushes. Secondly, we had all the handles on the brushes look like they are the same color. So if we look at that, looks to be true. All right, and then if we look again, it looks like we have different size brush heads. right? We have some very small ones and some very large ones. We also have brush heads that come in either different colors or different materials, right? So there's 3 more observations about the brush heads that we could add. All right. One thing that we want to be careful of that we do not want to add to observations, or we do not want observations to be explanations, assumptions, guesses, or opinion. Right, so these are not factual observations. We want to keep them out of our observation list. All right. And then another question that somebody came up with, or observation, was that water was being used to rinse a brush. All right, so there were lots of possible observations. One of the questions that we came up with, actually, I'm going to ask you to pause this and make your own question and then come back. Okay, so hopefully you've tried to formulate your own question. One question that we could make based on this observation is we could say, does it matter if we use cold or hot water to wash the brush? All right, so we can ask that question. And we can then take that question and turn it into a hypothesis. So if you asked a different question, you can take this opportunity to either rephrase your question if you need to, and then try to come up with a hypothesis where you're restating the question, making a testable, measurable prediction, and then giving a reason. Okay, so pause the video and make a hypothesis. Okay, so I'm going to go through the hypothesis I would make for this question. I could say something like, if the brushes are washed with warm water, then they will get cleaner faster, because warm water dissolves most substances better. Okay? All right, so that's an example of our warm-up. Now I'm going to show you guys a demonstration, and when we get towards the end of the demonstration, I'm going to let you know when it's time to come back to this and start collecting observations. Most of you guys know what this is, right? This is a penny. We don't use them very often anymore, but we've all seen them. And one of the reasons we know it's a penny is because of the color it has. And most of us will also recognize that color as the color of copper, right? And so things that have this color, we instinctually know that those things are made of copper, or at least have copper on the surface, right? But copper doesn't always stay like this. Copper is an element, and if we get copper, it has to come from rocks. It's mined from rocks. And so here's a rock. Let's see if I can put some light on that. Here's a rock that has some natural copper in it, and over time that copper has reacted with the air and moisture to form a crystal green substance that is made of copper and oxygen. So we call it copper oxide, right? And over time, we see some similar things happening with our nice shiny new pennies. So that's a new penny, but here's a penny that's a little older. You notice it's got kind of a greenish substance on it, which looks very similar to what I have on this rock. And here's an even older penny that's got more of this stuff on it. Okay, and so when pennies are near moisture, in air, this happens. And so a good example is the Statue of Liberty. When the Statue of Liberty was first made, it was this color. All right, but now there's a copper oxide coating on it that gives it that nice green color that we're used to. All right, so that's where copper comes from, and that's how we generally see copper. And now I'm going to ask you about another element. So copper is an element, but copper oxide is a compound. And so here's another element. Right? Most of us would recognize this. We use it for our food. Right? And this is aluminum foil. Some people call it tin foil. That was its old name because aluminum used to be really hard to get by itself. It wasn't until a little over 100 years ago that a method for taking the aluminum out of rocks made it much less expensive and efficient to get aluminum. Before that, aluminum would be locked in rocks like copper is, and it was very difficult to purify it. So nowadays it's easy to do, and aluminum is cheap because of that. But imagine you're a scientist working in a laboratory 150 years ago, and you've got this really valuable piece of aluminum. Well, not very many people have aluminum, right? Because it's hard to get. So you've got some aluminum, and maybe because you're working on purifying ores, you know, maybe you have some copper laying around, and maybe that copper has been sitting around for a long time. Maybe it's locked in with other substances too. So I have this compound here. You can see it's kind of a greenish color. And this is also a compound of copper. It's not pure copper. It has a color like the copper oxide. But it's not copper oxide, it's actually copper chloride. Okay, so different elements can make different compounds. So if I put a little bit of this copper chloride on here, let's say we're in the lab, and I had a little spill, okay, because sometimes labs get a little messy, and sometimes things get bumped into each other. That's how some of the greatest inventions were discovered. And now, because my lab wasn't super tidy, right, obviously there's already one spill here. Now let's say that I've spilled a little bit of water on this too. So here I have a bottle with a dropper, and all it is tap water. Okay. Now let's see what happens when I accidentally, quote unquote, spill some water on this aluminum and copper chloride. Now this is where I'm going to want you to watch carefully and then make some observations. That's better. Make some observations in your notebook. So watch first, then you can rewind this video and record some observations. Okay, so here's a few drops of water from the faucet. So I don't know if you guys can see, but there's a little bit of steam there. All right, so what happened? You still see some bubbling. I'm not sure if you guys were able to hear the hissing noise, the sizzling noise. And it's still bubbling a little bit. Okay, so let's see if we can zoom in on this a little bit. Okay, can you see that? So there's still some stuff going on there. All right, so at this point, you're probably making some observations that you can be putting in your notebook. All right, so here we have our aluminum foil. Oh my, look at that. We actually have a hole in our aluminum foil. I had 2 layers of aluminum foil here. Wow, look at that. So I don't see any green left. And it looks like some of our aluminum foil disappeared in this process. Although we know things can't truly disappear, they can only change form. Okay, so think about everything involved in that. And surely you can come up with 3 to 5 observations for that you can add to your notebook. And then I would like you to think of a question. This is very interesting to see. And I'm sure that you can come up with several questions, but you only have to do one. Okay, your last task is to write a hypothesis for this experiment, or for this demonstration that you saw. And your hypothesis should make some sort of prediction about maybe what happened to the water, maybe a prediction about what happened to the copper chloride, a prediction about what happened to the aluminum, okay? So you're going to write some sort of hypothesis that is both testable and measurable. All right, when you guys are done with this, then you can go to our Canvas homepage, and you're going to go to your assignment for this week. That's assignment 2 right here. That's what you put on page 5 of your notebook. If you're in periods 1 or 3, we did this assignment on slides. Okay, so you can still turn in slides, but if you would rather do it this way and turn in a picture of your notebook, it's fine. Okay, so all the other periods, you're going to take a picture of page 5 of your INB, and you are going to submit it in this page right here. Okay, there will be a submit button for you, and if you don't know how to take a picture, I have just sent out an email of a video explaining how to do that, and I will post it in here as well. Okay, I will see you guys later. Bye-bye.